For warm-up activity 4, find the volume of the solid revolution formed by rotating the rectangle shown about the indicated axis. First up, we have the x-axis. So I'm going to draw some pictures here for you. Help us visualize what's going on. So x-axis, let's go ahead and draw. Ooh, okay, no, that's looking like trash. Try it again. Come on, concentrate. Like this. Okay. And then I need a rectangle, and that rectangle is like this kind of a violet color. So let's go like right there and here. Does that look about good? It should be kind of skinnier than that, I think. Yeah, let's redo it. Oh yeah, now that's looking good. Look how straight this side was. It's like it was manufactured by a computer. All right, now I'll color this thing in this nice kind of purpley color. Very, very nice. And since I'm going to use this drawing a whole bunch, I'm just going to copy it real quick so I don't have to draw this perfect drawing 1,000 times. So let's copy it. Excellent. All right, the first one that we are going to do is that we're going to revolve this thing around the axis that just disappeared there, around the x-axis. Okay, so here's what I tend to do. Like, for example, this edge that's right up here, it will be the same. Think of it as a reflection down here in quadrant number 4. It's going to be the same distance y from the y-axis. That's where I usually start, is just drawing that thing there. And then I'm going to, like when I rotate this around, it should be a cylinder. So I'm just going to connect this edge to that edge with a nice kind of curve like that. Yeah. Okay, and then the other side of that thing. So you can see that makes roughly a cylinder, and then maybe I do the same thing over here. And if you want to, you can kind of dash the one that you're not supposed to see. So you can see that, where are you going? You can see this purple rectangle. When I rotate it around, this is the three-dimensional shape that it's supposed to make. And I need two quantities in order to find the volume of this thing. Here, let me center this, makes it look prettier. I need a radius and I need a height. So my height is this segment that's right here. And according to this picture, it is a height of 3. That'd be 3. Right? And then here's, of course, our radius. And looking at the picture, that radius is a 6 this time. So is 6. Okay. So its volume calculation should simply be pi times my radius. My radius was 3, which no, it isn't. It's 6, which I will square and multiply that times 3. Got 36 times 3. That'd be 90 plus 18. That's 108. Throw some pi. Throw a units cube on there. Make your geometry teacher happy. There you go. You've got yourself the x-axis rotation. Solid revolution makes a cylinder. This is what we call the disk method, basically. Right? Okay. Let's do this again, but this time we want the y-axis. This is where my copy and paste feature comes in pretty handy. Let's paste that thing. Okay. All right. And it needs to be labeled, because we're doing this around the y-axis this time. Here's a question for you. Is this going to make exactly the same, really, the exact same volume? Right? It's the same rectangle. Is it going to make the same volume? Well, think about it for a second. Is it going to have the same radius and the same height? Answer to that question is no, it is not. All right, because they're going to basically switch this edge over here, it's going to reflect over here in quadrant number 2. So I'll start by drawing that thing and then connect these pieces. So here is kind of the top base circle. Then we have one down here, and then maybe dash in the one that we can't see. Look at that, it's gorgeous. All right, I want to extend this out just a little bit more. Yeah, that looks good. Okay. All right, so now then, this piece that was 3 before, it was the radius of 3. no, it was the height of 3. Now it becomes the radius of 3. And this 6, which used to be the radius, is now the height. So you can see, obviously, these things switch. You're not going to get the same number. So it's 3 squared multiplied times 6. We get a 9 times 6, 54. All right, I've got an alarm going off for some reason. I think it's time to go to school. Okay, units cubed. Boom. All right, we're halfway there. We're going to do x equals 3. So I'm just, you know what? I'm just going to draw this right here on, what color would look good? Maybe green. Okay, here's x equals 3. If I revolve this around x equals 3, notice that it is essentially the same exact shape as the one around the y-axis, right? I could, if I wanted to, come over here with my purple crayon. Now this shouldn't be dotted, it should be solid. Yep, there you go. And then you kind of connect these and this thing and one of these guys, and then like that, you can see that it's the exact same shape. It has the same radius and it has the same height as the one that whenever I revolved it around the y-axis, it should have the exact same volume. All right, check mark. That one is done. And then finally, y equals 7. Now I promise you that this one is going to be different. Okay, delete, right? Because here we're revolving it around green again. Okay. This horizontal axis y equals 7, and when I revolve it around, do you see this little white space that's right here? It's going to create a hole. So think of this as like a roll of toilet paper. Let's see if we can draw something like this. And this should be the last one. You know what? I'm not sure. I'm not convinced entirely that there's going to be enough space. So I'm going to add an extra page. Boop, boop. And then let's do our copy and paste feature. Paste. Yes. All right, now this is going to need some more y-axis up top. So let me just move this down a little bit more and extend this y-axis up here. Okay, and then let's put our green axis in there that we had before, which was roughly about there. Okay. All right, so once again, I'm going to do the same kind of thing that I did before, and that is draw in the reflection of parts of this rectangle here. So this edge is going to be reflected. It's going to be like right up here. Let's draw that one in. Okay, that one, should it be dashed? I don't know, I think so. All right, and then this one down here is going to reflect approximately right there. Right. Okay, and now it's time to connect some stuff. So here we go. Right, okay, and then same kind of thing over here. This is looking good. All right, now inside here, this is where we have our little hole, like that, and then let's dash this one. And then if you want to, you can kind of dash this guy in the background. Can you see that washer? That's exactly what this thing went. This is a washer. This is y is equal to 7. This is this geometric shape, we call it a washer. Actually, it's a three-dimensional one. A washer would just be, it's sort of like a compact disc, got a little hole that's right in the middle. I said compact disc as if you guys knew what the heck that is. Anyway, all right, so how would we find the volume of this thing? Well, it's just basically a cylinder with a cylinder hole in it, so we can do it by subtraction. We would do basically this kind of thing. We would do volume is equal to the volume of the, let's say the big cylinder minus the volume of the small cylinder, sort of like that, right? Yeah, right. So I need a radius and I need a height for each one of these little cylinders. Let's draw this thing in here. Let's start with the big one. So with the larger one, which is this guy that's right here, V sub B, we need a radius. So the radius extends from this axis of revolution all the way down to the x-axis. And remember that this was the line y equals 7. So it's like 7 up from the x-axis. So obviously it's 7. You can do 7 minus 0 if you want to, but it's, you know, it's 7. Okay, and then its height is still this 3 that's right here. So far we've got our volume is going to be pi times 7 squared, and then multiply that times a 3 minus, all right, and then I'm going to take away the whole. So the whole here extending from basically this axis of revolution down to this bottom edge of the hole, that's 1, right? If I come back up here to this one, you can see that that is going to have a radius of 1, but it's still going to have a height of 3, right? The same exact height as the whole entire thing. So this is 1, right, with the laser, 1. And the way that I could have gotten that, notice that this is basically 7 for the axis and 6 for the top edge of that. 7 minus 6 gives us the 1. See, sort of like the area thing, it's like top minus bottom, right? Yeah, it's like top minus bottom. Okay, yeah. All of that means that now I'm going to subtract out pi times my radius. My radius was, we said 1, and then multiply it still by the 3. Okay, and now what you could do if you wanted to, it's like they both have a pi in it. So watch, I'm just going to do this like algebra stuff. I'm going to take a pi out of the front and have a 7 squared minus a, I forgot to square the 1. Oh my gosh, what a mistake. And then also factor out this 3, but I'm going to factor it out over here. Why am I doing that? Just because. Just go with it. Okay, you'll see why calculus. Anyway, yeah. So, I mean, I could work that out. I could safe stop it if I wanted to. But you know what? I can possibly handle this. Let's see. I've got 49 minus 1 times 3, beep, which is a 48. So basically a 48 pi. Then I'm multiplying times 3. That'd be 120 plus 24, I think. So 144 pi's. Units cubed. I'll check that with a calculator, after I end this video just to make sure I did my math right. And if I didn't, maybe you're screaming at the screen right now. But I think that's it for right now.